Hello and welcome. You see carbon fiber everywhere these days, from supercars and aircraft to high-end bicycles and tripods. It's famous for being incredibly strong and fantastically lightweight. But have you ever stopped to think, is this wonder material conductive to electricity? The simple answer is yes, it absolutely is. However, the full story is far more complex and has massive implications for how we use it. Today, we're going to dive into this topic, explaining not just if it conducts, but how well it conducts, and why that matters so much. First, let's understand the basic why. Carbon fiber is made from, as the name suggests, carbon atoms. These atoms are arranged into long, tightly interlocked chains that form microscopic crystals aligned parallel to the fiber's axis. This structure is similar to graphite, which you know from your pencil lead is a conductor of electricity. In this crystalline arrangement, some electrons are not tightly bound to the atoms and are free to move along the length of the fibers. The flow of electrons is the very definition of an electric current, so this is what gives carbon fiber its conductive property. But here is the most critical point: how well does it conduct? Compared to a metal like a copper wire, carbon fiber is actually a pretty poor conductor. Think of it this way: if copper is a super wide, multi-lane highway for electricity to flow freely, carbon fiber is more like a narrow, bumpy country road. Electricity can still travel down it, but it faces a lot more resistance along the way. This property of being a resistive conductor is both a benefit and a major hazard. On the positive side, this resistance means that when you pass a current through carbon fiber, it heats up. This makes it an excellent material for heating elements in things like heated car seats, heated jackets, or even de-icing systems on aircraft wings. Its conductivity also allows it to be used for EMI and RFI shielding, essentially creating a cage that can protect sensitive electronics from outside interference. However, the dangers are very real. Because it conducts electricity, a piece of carbon fiber can cause a short circuit if it touches a live electrical component in a car or an airplane, potentially leading to fires or system failure. This is also a huge concern for lightning strikes on aircraft. An aluminum airplane skin disperses the massive energy of a lightning strike very effectively. Carbon fiber composites don't do this as well, so they often need a special conductive material, like a fine copper mesh, integrated into their surface to handle lightning safely. Another major issue is galvanic corrosion. When carbon fiber is in contact with a metal like aluminum in the presence of an electrolyte like salt water, it can act like a battery and cause the metal to corrode extremely quickly, which can be catastrophic for the structural integrity of a vehicle or part. So, in summary, carbon fiber is definitely conductive, but it's a resistive conductor that sits somewhere between a true insulator like plastic and a great conductor like copper. This unique property creates both amazing opportunities and very serious engineering challenges that must be carefully managed. Thank you so much for watching. If you found this video informative and want to see more deep dives into the materials that shape our world, please consider supporting the channel by liking this video and subscribing. Your support makes it possible for us to create more content just like this. We'll see you in the next one.